Welcome to The Explainer. All right, today we're talking about a massive shift in how we build everything. Think about it. Airplanes, cars, you name it. Artificial intelligence is now baked right into the tools engineers use every day, and it's completely changing the game of design. So let's kick things off with a really big question. How do you design something that's just too complex for the human brain to even imagine? I mean, as we push for better, stronger, lighter products, we're hitting a wall. The parts we need are so ridiculously optimized that they're beyond our own intuition. Okay, to really get where we're headed, you gotta look back at where we've been, right? So back in the 70s, CAD was basically just digital drafting, moving from paper to a computer screen. Then in the 90s, we got smarter with simulation and managing a product's entire life. But what's happening now, this whole AI integration thing, it's a totally different ballgame. We're not just using tools anymore, we're collaborating with them.
All right, let's really get into it. This is about so much more than just drawing faster. It's about a whole new way of thinking.
You know, when you picture traditional design, you probably think of straight lines, perfect circles, very mechanical stuff. But the parts we need today, for lightweight jets or next-gen batteries, they look more organic, almost alien. To get that level of performance, to make things lighter and stronger than we ever thought possible, we've had to admit that our own brains have limits.
And that's exactly where AI comes into the picture. Now, when we say AI in engineering, it's not some single magic button. It's like a whole team of super intelligent assistants. They can learn from tons of data, spot patterns that a human would totally miss, and just churn through millions of design ideas to find the perfect one. Okay, now for the really cool part. This is where AI stops being just a tool and actually becomes a creative partner. We're talking about something called generative design.
So here's the absolute game changer with generative design. The engineer doesn't draw the part anymore. Instead, they just describe the problem. They tell the AI, look, I need a bracket. It has to be made of titanium, hold this much weight, and fit in this exact space. Oh, and it can't cost more than $50. And then, the AI goes to work. The process itself is actually pretty straightforward. Step 1, the human sets the rules of the game, the goals and all the constraints. Step 2, the AI just goes wild, exploring this huge space of possibilities, coming up with thousands of different options. And finally, step 3, it brings back a handful of the best designs, and the engineer gets to be the final judge. And the benefits here are just huge. First, you get these totally unexpected solutions, designs that look more like something out of biology than an engineering textbook, just wild, nature-inspired shapes. And the second thing is pure, unadulterated speed. A design cycle that used to take a team of people weeks, now it can be done in hours. It's incredible. So generative design is amazing for dreaming up brand new stuff, for sure. But AI is also becoming this super smart assistant for, the everyday, nitty-gritty design work. Let's take a look at how that plays out. To really get what AI does here, we need a quick primer on how designers actually build 3D models. So, you've got parametric modeling, which is kind of like following a recipe. It's all based on rules and history. Then there's direct modeling, which is more like sculpting clay. You just push and pull things around. They're both useful, and AI is actually helping to connect them. Okay, so picture this. You get a 3D file from someone, but it's just a dumb solid. There's no history, no recipe. Normally, that's a huge pain. But an AI with feature recognition can look at that shape and instantly act like a veteran engineer. It'll say, yep, that's a hole, that's a slot, that's a rib. It understands the purpose of the geometry, and that saves a crazy amount of rework. Now this might be my favorite part. It's called surrogate modeling, and you should just think of it as a digital crystal ball for engineers. See, running a full-blown physics simulation to test a part can take hours, sometimes even days. But a surrogate model? It's been trained on thousands of those simulations, so it can predict the result almost instantly. And when I say instantly, I'm not really exaggerating. We're talking about an evaluation that's up to 1,000 times faster. 1,000! An engineer can tweak a design and see the impact right away, instead of waiting overnight for a simulation to finish. So what does that mean in the real world? It means you could potentially slash the time you spend on simulation work by as much as 70%. That's a huge chunk of the development schedule, just gone. And you might be thinking, okay, it's fast, but is it accurate? Well, yeah. We're typically seeing prediction accuracy of 85% or even higher. It's not meant to replace that final perfect simulation, but as a guide during the design process, it's absolutely reliable. Okay,
So we've dreamed up these incredible, complex, almost alien-looking parts. But that leads to the big question, right? Can we actually make them? This is where AI closes the loop between the digital design and the real-world factory.
AI's brainpower doesn't just stop at the design phase. It follows the part right onto the factory floor. In manufacturing, it's like having a master machinist inside the computer. It'll automatically spot features and suggests the best tools for the job. It finds the absolute fastest path for a machine to cut the part, saving time and money. It can even predict when a tool is about to break, which prevents a ton of headaches.
And honestly, this is the connection that makes it all work. Without this smart manufacturing piece, all those amazing organic shapes from generative design, they'd just be pretty pictures on a screen. AI on the factory floor is what makes them real, manufacturable, and scalable.
All right, so with all this incredible new power, the power to design, test, and build at superhuman speeds, comes a whole new set of responsibilities. We have to talk about the human side of all this.
This quote from the material we're looking at really nails it. It says AI and CAD isn't just a tech upgrade, it's a professional paradigm shift. That means the job itself is changing, and we need a strong ethical compass to navigate it.
Because think about it, when an algorithm is creating the design, that raises some big questions. First, bias. We have to be super careful about the data we train these AIs on. Then there's accountability. If something goes wrong, who's responsible? We need rock-solid traceability. And finally, transparency. We can't have black box systems. The AI needs to be able to explain why it made a certain choice, so the human is always in the driver's seat.
And all of this leaves us with one last massive question to chew on. If the AI is the innovator, the artist, the optimizer, what's left for the human designer to do? Maybe their job isn't about drawing lines anymore. Maybe it's about asking the right questions, being the conductor of this AI orchestra, or serving as the ethical guide. The role is definitely shifting, from being the creator to becoming the curator.